And in this video, we're going to be using the partial products method along with the distributive property as well as expanded form to multiply multi-digit numbers by single-digit factors. So let's get started. So to start things off here, let's take a look at the number 37 times 6. When we go to multiply 37 times 6, what we really need to do is figure out what makes up 37. So we know that 37 I can decompose, and that 3 right there, that's worth 30, and that 7, that's just plain old 7. I can decompose, and that's an important term for you to know. To decompose the number means to break it up into each of its values for the different places based on place value. So I've been able to decompose my number, and really I'm writing this as expanded form right here because we know that 30 plus 7 equals 37. So I'm also using expanded form. So in this particular problem, I've got 37 times 6. I've managed to decompose 37 into 30 and 7, and both of those parts need to be multiplied by 6. So I'm going to have 30 times 6, and I'm going to have 7 times 6. So I can rewrite this problem as 30 times 6 plus 7 times 6. And the way that I've written it right here, it may not be the clearest, but it is a correct way to write that. Although if I want to make this even better, I'm going to throw in some parentheses to show how I can group it together. And I can solve this, and I can say, well, let's see. 30 times 6, well, I know that 3 times 6 is 18, so 30 times 6 has to be 180. And I've got 7 times 6. 7 times 6 equals 42. And I can add these together, 180 plus 42. If I can add it horizontally, that's fine. Otherwise, I can rewrite it certainly as vertical, 180 plus 42. 0 plus 2 equals 2. 8 plus 4 equals 12 plus 1. I've got my answer of 222. So that worked out pretty well for me using decomposing and the expanded form. And by the way, we're also using here the distributive property in order to multiply because I'm taking my times 6 and I'm distributing it across the different expanded forms of 37, the different place values. I did the times 6 times 30 and the times 6 times 7. So I'm also using the distributive property. But here's the thing. Let's say I had a slightly larger number that I was working with, like 492 times 3. Well, I can still go through the same process here. I can decompose it into its different forms. 490 and 2. And I know that if I wanted to look at that in expanded form, that's 400 plus 90 plus 2 equals 492. Just a good way of checking that over. But again, I still need to make sure that all three of those are subject to the times 3. Then I'm doing 400 times 3, 90 times 3, and 2 times 3. So there are a couple of different options that I have. Just like I did before, I can use the distributive property here, and I can write that as 400 times 3 plus 90 times 3 plus 2 times 3. And I could work to solve that. But sometimes it can get a little unwieldy because look how long this equation is. Imagine if instead of working with a number in the hundreds, if I was also working with something in the thousands, that would add yet another place that I'd have to put in my numbers here. It would really start to get a little time consuming and just a little cumbersome on paper. Plus, when I go here to do my multiplication, let's see, 4 times 3 is 12. So 400 times 3 is 1,200. 90 times 3, well, I know that 9 times 3 is 27. So 90 times 3 has to be 270, and 2 times 3 equals 6. Now I have to go and add these up. This is a tough thing for me to add in a horizontal equation. In my last problem, in fact, when I had to do 180 plus 42, I decided to rewrite the problem as a vertical equation. So, maybe I should do that here as well. I'm going to show you a way that you can do all the same math as what we did right here, but to organize it so that it's a little bit easier to work with. I'm still using decomposing numbers. I'm still using expanded form, and I'm still going to be using the distributive property. All of that's the same. I'm just going to write it in a different way. So instead, I'm going to recopy my problem and make 492, but I'm going to write it as a vertical addition. Vertical multiplication. You also sometimes hear that called stacked multiplication. 492 times 3. You'll notice that I've left plenty of room to the left of the problem. I'm going to need that right here because when I decompose it, I can still draw my number bond. By the way, another important term for you to know, when you decompose the number and you draw these branches to show, for example, 492 is really 490 and 2, we call that a number bond. So I can still use that information to help me because I know that I'm not just doing 492 times 3. I can break that up and say that I'm doing 400 times 3. So just like we had that before up here, I'm going to rewrite that down here. 400 times 3. And now I know that I also have to do 9 times 3. 90 times 3. I had that written up here before. 90 times 3. And then lastly, 2 times 3. This 2 is just a plain old 2. So I've got 2 times 3. And now I'm going to write my partial products here. They're not products to the entire thing. It's really important, by the way, as I do this, that I keep my numbers lined up. You'll see why in a moment. So I'm going to do this as just a easy way for myself to keep my numbers lined up. You don't necessarily have to do this. Sometimes I encourage kids to do their work here on graph paper just because it already has columns to help them out. 400 times 3 is 1,200. So I've got 1,200. 90 times 3 is 270. I'm using my extended facts to help me. And 2 times 3 equals 6. And now this is a lot easier. Before I had 1,200 plus 270 plus 6. That horizontal method was a little bit tough when I had to regroup. But here it's going to be a lot easier for me. I can do 6, 7, 2 plus 2 equals 4. I guess I'm not really regrouping, am I? 1,476. So that's my product. Now, oftentimes we look at that and we say, okay, is 1,200 a product? Yeah, it's a product. It's a product of 403. That's my product here. 270 is a product of 90 and 3. 6 is a product of 2 and 3. These are products, but they're not the overall answer. They're not the whole product of 492 times 3. They are what we call partial products. And that's why when we talk about using the distributive property, decomposing our numbers, using expanded form, those are a lot of terms that you'll hear. But really, the name of this strategy, especially the way that I've drawn this out right here, is the partial products method, because we're breaking down our multi-digit factor, we're decomposing it, and we're multiplying it in order to get partial products, which will then add together in order to get our final product. Let's do one last problem as a practice, and this time we're going to go straight to the partial products method. If it helps you, by the way, let me go back for a second. If it helps you to draw the number bond and to write out your equation in more of the traditional distributive property using parentheses, that's fine. I'm not telling you to change that. But for this next example, I'm going to kind of jump ahead here a little bit. I'm still going to draw my number bonds because I just really think that that helps me out here. That's 680 and 3, and they're all going to be multiplied by 9. So I'm going to rewrite this problem. 683 times 9. So now what I have to do is figure out my partial equations. So my 6 here I know is worth 600. So that's going to be 600 times 9. So I'm going to write that over here. 600 times 9. My 8, that's worth 80. So I'm going to do 80 times 9. And my 3 is worth 3. So it's going to be 3 times 9. So now I'm going to set it up. Let me draw for myself because it helps me. Some lines here to keep my math organized as I'm going along. You don't necessarily have to do this. It's just really important that you keep your numbers carefully stacked up here. So I've got here 600 times 9. Well, I know that 6 times 9, 6 times 9 is 54. So 600 times 9 is going to be 5,400. 80 times 9. Well, I know 8 times 9 is 72. So 80 times 9 has to be 720. And lastly, 3 times 9. 3 times 9 equals 27. So now what I'm going to do is add up my numbers. 0 plus 0 plus 7 equals 7. 0 plus 2 plus 2 equals 4. 4 plus 7, see now I'm doing some regrouping here, is going to be 11. I'm going to regroup my 1. 5 plus 1 equals 6. And my product is 6,147. That's my final product. But to solve this, I was using partial products here, and that's why we call this the partial products method. This has been Mr. Moss giving you an introduction to using partial products, as well as the distributive property, the expanded form, number bonds, decomposing. It's all good stuff. And we've been multiplying multi-digit numbers by single-digit factors. I hope this was a helpful guide for you. Have a great day.